Hi there, this is T sequences and estimations, and I'm just going to run through a few different types of sequences and also a few little estimation problems, but nothing too strenuous. Let's start off. What type of sequence is this? And it goes from 64 to 32 to 16 to 8 to 4. Now, a lot of us are able to just pick it up. That's going to be a decreasing geometric sequence. However, one surefire way of doing it is pair them up and look at the differences, and that's where you usually will find your pattern. Case in point, I'm just going to do another sequence here just to kind of show you the difference. If it was, I don't know, minus 32, then this would be 0, then this would be negative 32, negative 64. And what I'm trying to show is that this would be a descending arithmetic sequence. So I'll just call it an A sequence, okay? And this one I'm going to call this a G sequence. So how do we know that this is a geometric sequence? First of all, this one, the differences right here is 32 initially. Then it gets smaller, it goes to 16. Then it gets smaller, it goes to 8. Then it gets smaller, it goes to 4. You can see that the differences are being cut in half each time. So you can actually go from one difference to the next and find out what the drop is, and that would be by 1/2, by 1/2, by 1/2. So this would be 1/2 kind of like multiplier to each problem, or each number, to go to the next sequence number. So it'd be 64 times 1/2, 32 times 1/2, things like that. Okay, and notice with the arithmetic sequence, it goes 64 to 32, so that's going to be a difference of 32, difference of 32, difference of 32, difference of 32. See how the arithmetic sequence, it doesn't change. So that's how we can kind of tell whether it's a geometric or an arithmetic sequence. The differences will remain constant in the arithmetic, and in geometry it will change. So what is the next sequence? Let's go on to the next problem. What is the next number in the sequence? I don't know. Let's see. Well, the difference here is going to be 6. And then it's going to be 18. Then it's going to be some god-awful number, which I'm just going to let my little dilly-do do. Great. And now this is how we tell what would be the next number in the sequence. Well, the difference is, if you take 18 divided by 6, that's 3. So you see that basically each time we're multiplying by 3. Multiplying by 3. So what we need to do is we need to multiply by 3. The difference needs to be 54 times 3, which is going to be 162. So 81 plus 162, 243. And let's just check if that works. 81 times 3 is going to be 243. 81 times 3, that equals 243. Kind of a nifty technique of doing it, huh? Alright, so what's the next in the sequence? The next problem. Once again, you have a differences of 1/2, differences of 1/4, differences of 1/8. You're almost going to be able to pick up the pattern. 1/2, 1/4, 1/8. This should be 1/16. Notice how the bottom is just being multiplied by 2 every time. So that will give us 1/16 as our solution. So you'll realize that you do get an intuition about it, but don't be afraid to just fall right on back. Because when someone starts switching out letters for numbers, as you see in a lot of these brain teaser books, all you do is you just switch the differences into a numerical difference, and you'll see a pattern real easily. So let's go on to the next problem. If you have $7.10 in dimes, how many dimes do you have in total? Well, we know that 10 cents equals a dime. Thus, we can say that $1 equals 10 dimes. So all you do is you just say, I have $7. I have $7. And you multiply it by 10 dimes over $1. And that'll equal 70 dimes. Plus, and then to get $7.10, so plus the 10 cents, plus 1 dime. So it'd be 71 dimes. Not too bad. Alright. Here's an interesting problem. If Andrew is 11 years younger than his sister, and she is half the age of her dad, how old is Andrew if his father was born, or was 22 when his sister was born? Alright, so let's write out a bunch of equations. We have Andrew is equal to, I'm just going to call sister S minus 11. I'm actually going to write this in another way. Andrew plus 11 equals sister. Okay? Then, my sister's half the age of dad. So, sister equals 1/2 D. Okay, so we have this function now. And this function. Let's keep going. If my father was born 22 when my sister was born, so that means D equals S plus 22. Okay, so I think we could probably figure it out at this point. You could probably just figure it out straight from that. Let's slap these two functions together, okay? You get D is equal to S, but I'm going to plug in that 1/2 D. 1/2 D plus 22. Well, what we can find out here is that if we subtract this D over, kind of get the D's alone, you'll have 1/2 D equals 22. Thus, D is equal to 44. Then we just fall back. If my dad's 44, my sister's half of that, so the sister is 22. And Andrew's 11 years younger, so, A plus 11 equals the sister 22, A equals 11. It's not too bad modeling it, but it's always good to just draw it out, especially if you have multiple functions like this. I like to box each significant function, and that way I don't lose track of anything. So anyway, I'll see you guys in another video. Have a good day.